In this session, we discuss about sensible heat, latent heat of evaporation, and heat of superheat. First of all, sensible heat, which is generally denoted by HF. Sensible heat it is denoted by HF. Now, it is the amount of heat energy required to raise the temperature of unit mass of water at given pressure to its saturation temperature Ts. Means it is the amount of energy required to raise the temperature of unit mass of water to its saturation temperature at given pressure. Now, to calculate the value of sensible heat, we can use the equation HF equal to Cp dt. Now, here the Cp is the specific heat at constant pressure. dt is the temperature difference, or at a given pressure, value of HF can be found out from the steam table. Otherwise, the value of HF can be calculated by using this equation. HF equal to 4.2 into Ts, where Ts is the saturation temperature and it is taken in degree centigrade. So, this is sensible heat. ગુજરાતીમાં વાત કરીએ તો સેન્સિબલ હીટને સંવેદનશીલ ગરમીના નામથી ઓળખવામાં આવે છે. 1 કિલોગ્રામ પાણીને આપેલા દબાણે અને આપેલા તાપમાને થી તેના સંતૃપ્ત તાપમાન સુધી લઈ જવા માટે જે ગરમીની જરૂર પડે છે તે ગરમીને આપણે સંવેદનશીલ ગરમીના નામે ઓળખીએ છીએ. તેની કિંમત HF ઇક્વલ ટુ CP dt દ્વારા મેળવવામાં આવે છે, જ્યાં CP એ વિશિષ્ટ ઉષ્મા અચળ દબાણે છે. બીજો ટર્મ જે વપરાય છે એ છે લેટેન્ટ હીટ ઓફ ઇવેપોરેશન. લેટેન્ટ હીટ ઓફ ઇવેપોરેશન તેને HFG વડે દર્શાવવામાં આવે છે. લેટેન્ટ હીટ ઓફ ઇવેપોરેશનને HFG વડે દર્શાવવામાં આવે છે. It is defined as the amount of heat required to convert 1 kilogram of saturated water into dry and saturated steam at given pressure. લેટેન્ટ હીટ એટલે કે અચળ દબાણે આપેલા દબાણે 1 કિલોગ્રામ સેચ્યુરેટેડ વોટરને ડ્રાય એન્ડ સેચ્યુરેટેડ સ્ટીમમાં રૂપાંતર કરવા માટે જે ગરમીની જરૂર પડે છે તેને આપણે HFGના નામથી ઓળખીએ છીએ. લેટેન્ટ હીટ ઇઝ ડિફાઇન્ડ as the amount of heat required to convert 1 kilogram of water at saturation temperature Ts corresponding to its pressure P into dry and saturated steam at the same pressure and temperature. હવે આ લેટેન્ટ હીટ જો આપણે વેટ સ્ટીમ માટે શોધવા માંગતા હોય, એટલે કે if you want to define, this is the latent heat for dry and saturated steam, okay, and if you want to define the latent heat for wet steam, Then latent heat of wet steam of dryness fraction X is the amount of heat required to convert 1 kilogram of saturated water into wet steam of dryness fraction X without change of temperature and pressure. Now, this H weight means it is the enthalpy or the latent heat of wet steam. It is H weight and it is calculated by equation X, which is dryness fraction, into HFG. This value of HFG can be obtained with a steam table at given pressure and temperature. The unit is kilojoule per kilogram. Okay, so first is sensible heat, second is latent heat, and it is further divided or further there are two types. One is latent heat of wet steam and another is the latent heat of dry and saturated steam. The third term is used is heat of superheat. Heat of superheat. Now, this heat of superheat is defined as the amount of heat required to convert 1 kilogram of dry and saturated steam into superheated steam at temperature T sub at constant pressure. Means once the steam is formed and it is converted, the water is converted into dry and saturated steam. Now, if you further supply the heat to this steam, then the temperature of this steam will raise to superheated temperature, means it raise above saturation temperature of steam. So that steam is known as superheated steam, and the heat required to raise the temperature of formed dry and saturated steam from its saturation temperature to superheated temperature is known as heat of superheat, and it is calculated by dH, means it is the heat of superheat. It is calculated by CPS into T sub minus T set. Means here CPS is the specific heat of superheated steam, which varies from 2.1 to 2.7. This CPS is 2.1 to 2.7 kilojoule per kilogram Kelvin. Kilojoule per kilogram Kelvin. So this is the third type of heat we discuss. First is the sensible heat. Second is the latent heat. It is again in two types: latent heat of wet steam, latent heat of dry and saturated steam, and heat of superheat.